Question. Let Dn be the number of divisors of n. That is, the number of positive integers that divide n. For example, d5 is equal to 2. Why 2? Because 1 and 5 are the only two positive integers that divide 5. Similarly, d6 is equal to 4. Why? Because 1, 2, 3 and 6 are the only four positive integers that divide 6. Then we have to find the sum of the digits in E, where E is the summation of -1 raised to the power dn, and the summation is from n is equal to 1 to n is equal to 2024. Answer. It can be proved that a perfect square always has an odd numbers of divisors and other numbers have even number of divisors. If you do not know this, try to see a pattern by writing down the divisors for the first few numbers as shown in the table. In this table, we have taken numbers from 1 to 16. We have listed out the divisors for each number, and then we have calculated what is dn, or what is the number of divisors for each case, and finally we have also calculated -1 raised to the power of dn, and this we have done from 1 to 16. Notice that within this range, that is from 1 to 16, there are only 4 perfect squares. These are 1, 4, 9 and 16. And their divisors are, in the case of 1, only 1. In the case of 4, it is 1, 2 and 4. In the case of 9, it is 1, 3 and 9. And in the case of 16, it is 1, 2, 4, 8 and 16. So in the case of 1, there is only one divisor, so dn is equal to 1. Similarly, in the case of 4, dn is equal to 3. In the case of 9, dn is again 3. And in the case of 16, dn is 5. So in the case of all the 4 perfect squares, the number of divisors is an odd number. And take any in-between number, let us say 6. The divisors are 1, 2, 3 and 6, that is their number is 4. Similarly, if you take 12, you see that the divisors are 1, 2, 3, 4, 6 and 12, that is the number is 6. Notice that for perfect squares, -1 raised to the power of dn is equal to -1 raised to the power of x, where x is an odd number. Because x is an odd number, -1 raised to the power of an odd number will be -1, and this will be for perfect squares. For other number, the same thing will be -1 raised to the power of dn, that is equal to -1 raised to the power of y, where y is an even number. And minus 1 raised to the power of an even number is plus 1, and that is for other numbers. E is equal to summation of minus 1 raised to the power of dn, and the summation has 2024 terms starting from n is equal to 1 to n is equal to 2024. We know that the square of 44 is equal to 1804 and the square of 45 is 2025. Therefore, between 1 and 2024, there are 44 perfect squares, and 2024 minus 44, that is 1980 other numbers. The values of minus 1 raised to the power of dn for all the perfect squares will be minus 1s, and for all other these will be plus 1s. Therefore, the summation will be minus 1 into 44 terms plus 1 into 1980 terms, that is 1980 minus 44, which is equal to 1936. Our question is to find out the sum of the digits in this number, that is in 1936, and this is equal to 1 plus 9 plus 3 plus 6, that is 19. So the answer is 19.